Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have started amines. In that I have finished introduction and nomenclature of amines. Now I am going to discuss preparation of amines. Preparation of amines. Amines are prepared by reduction of nitro compounds. Amines are prepared by reduction of nitro compounds. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or platinum, and also by reduction with metals in acidic medium. Nitroalkanes can be also be similarly reduced to the corresponding alkane amines. Okay. Then first I am telling you reaction, that is from nitrobenzene. Nitrobenzene means in benzene nitro group is attached. Then nitrobenzene in presence of hydrogen gas and palladium and ethanol, directly it will convert to amine. Nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel, palladium or potassium. Then here reduction is going on. Then NO2. Then reduction means here hydrogen will be available. Then NO2, O2 will go as both oxygen will convert to water in presence of hydrogen. Here 2 oxygen is there, then 4 H will be required. Then it will go as a 2H2O, and at its place 2 hydrogen will join. In the place of oxygen, hydrogen will join. 2 hydrogen will join, and it will convert to amine. Okay, means in benzene ring NO2 was there, now it will be NH2. Second that is in presence of Sn plus HCl, also reduction can be done. In the presence of tin, stannous plus HCl or Fe plus HCl, a reduction can be done. Same thing will happen. Nitrobenzene, it will convert to NH2. Correct? Then this by reduction of nitro compounds, amine can be prepared. Reduction with iron scrap and hydrochloric acid is preferred. Means Sn plus HCl is preferred. Why? Reduction with iron scrap and hydrochloric acid is preferred because FeCl2 form gets hydrolyzed to release hydrochloric acid during the reaction. Here Sn plus HCl, correct, one condition. Other condition is or Fe plus HCl. Then this Fe plus HCl is preferred. Not this reduction with iron scrap. Correct. Reduction with iron scrap and hydrochloric acid means Fe plus HCl is preferred because FeCl2 form gets hydrolyzed to release hydrochloric acid during the reaction. Thus, only a small amount of hydrochloric acid is required to initiate the reaction. This is the one method. Okay. Similarly, nitroalkanes can also be prepared. Nitroalkane, here you have nitrobenzene you have taken, but you can take nitroalkanes also. Nitroalkanes can be also be reduced to the corresponding alkynes same way. NO2 will convert to NH2. How? I have told you that oxygen will just go as water in presence of hydrogen, and in the place of oxygen hydrogen will join. Now another method I am telling you, that is a ammonolysis of alkyl halide. Carbon halogen bond in alkyl or benzyl halide can be easily cleaved by nucleophiles. Here I am telling you ammonolysis of alkyl halide. Ammonolysis. Carbon halogen bond in alkyl or benzyl halides can be easily cleaved by a nucleophile. Hence, an alkyl or benzyl halide on reaction with an ethanolic solution of ammonia undergoes nucleophilic substitution reaction, in which the halogen atom is replaced by an amino group. Amino group means NH2. This process of cleavage of the CX bond by ammonia molecule is known as ammonolysis. What is ammonolysis? Then here I told you halogen atom is replaced by an amino group. This process of cleavage of CX, C means carbon, X means halogen. This process of cleavage of the CX bond by ammonia molecule is known as ammonolysis. The reaction is carried out in a sealed tube at 373 Kelvin. The primary amine thus obtains behave as a nucleophile and can further react with alkyl halide to form secondary and tertiary amines and finally quaternary ammonium salt. Reaction is simple. NH3, then in NH3, N has a lone pair of electron, one lone pair of electron. Then in the presence of Rx, R is alkyl group, X is halide. Then lone pair of electron of nitrogen of ammonia, that will be given to R, alkyl group, because X is electron negative, then R will be electropositive, because X will take the electron, obviously R will be positive, hence that R will take the lone pair of electron, and this with R NH2 will join, and after giving the lone pair of electron, N will become positive. Then now you got RNH2, where N is now plus charge. Okay, because it has given electron to R, means alkyl group. This is called actually substituted ammonium salt, because now N is positive charge and X is negative. Correct? Because this positive charge is there and X was there with Rx, then X was having negative. Then when N got positive charge, then X will come there only. Then positive charge, negative charge. RNS2, N is positive charge, Cl will come there, Cl minus. Then this is just like a cation and anion. It will form salt. This is called substituted ammonium salt. Okay. Now, only in this reaction further you can see change. RNS2, NS, you have taken NS3. You have taken NS3, correct? NS3 plus R minus X. Then you got actually RNS3, X you got. RNS3, N plus and X minus, that you got. That is a substituted ammonium salt. Till date it is a H3 is there, NS3. Only lone pair of electron you have given to R. Hence you got the salt. 3 H is there. RNS3, X. This is called substituted ammonium salt. Now, I only in this reaction further change you can observe that, or you can think like that. If RNS2 is there, primary amine, if primary amine is there, suppose starting material, now you have taken primary amine RNS2, then in presence of Rx, alkyl halide, now you think you have taken primary amine RNH2, and in presence of Hx, what will happen? Then now same way, now one more R will attach. NH2, two hydrogen is there. Then in the place of one hydrogen, one R will come. Then now it became 2R, means R2NH. Correct? And one H gone as H plus, and in Rx, then that X was X minus. Then H plus X minus, it will form HX, it will go. And R will, because H plus is H plus, H is going as a H plus, then obviously N will become negative, will become negative, then Rx, when X gone as X negative, then R become positive, then this R positive will join to N negative. That's why it became R2 and 2R joined with N. Till now one H is there, one H is there. Then now this is called secondary. Then now from primary amine you got a secondary amine. Now one more H is there, then same thing will happen, that H will also go. This secondary amine, if it will continue reacting with HX, then same reaction, third R will come. Third H will also go, and at its place R will come. Correct? And H plus and X minus of Rx, it will form HX. Then now you got 3R attached to the N. Then this is called tertiary amine. That is the 3 degree amine or tertiary amine. Now again you can see here you have started reaction with primary amine. That primary amine N was having lone pair of electron. What I discussed in the beginning, that was NH3. That reaction is over. Okay, that formed a salt. But now you are understanding primary. You have started reaction with primary amine. Then now all 3 hydrogen replaced. But now one more scope is there. One more scope is there for making bond. That is the 4th R also can join. How? Then now it is very clear that N has a lone pair of electron. Then that can make a bond with another R. Another Rx will be there, 4th Rx. Now every time with primary 1 Rx, with secondary 1 Rx, tertiary 1 Rx, now again 1 Rx. Then now what will happen? That R will join with nitrogen. So as nitrogen lone pair is given to R. Then Cl will be relieved as Cl minus. Then now we will get NR4. NR4 with N, 4 alkyl group is attached. But because N has donated its electron to R, hence N will become positive and Cl is there, Cl minus, it will form salt. NR4, N is plus charge and then Cl minus. This is the quaternary ammonium salt. This is called quaternary ammonium salt. Correct? The free amine can be obtained from the ammonium salt by treatment with a strong base. How? Then reaction is very simple. If you want free amine, okay, then you can get it from quaternary ammonium salt. Quaternary means 4, you remember. The free amine can be obtained from the ammonium salt by treatment with a strong base. RNH3X, it is the quaternary ammonium salt. RNH3X, correct? This is called quaternary ammonium salt. Then RNH3X plus NaOH. Then here what will happen? That here you will get 2 more product. You will get RNH2 plus H2O plus NaX. Means if X is Cl, then you will get NaCl, NaBr, NaI depending on X. X may be chloride, bromide, iodide. Then here that RNH3X was there. N was plus charge, X was negative charge. It is reacting with NOH. Then how it will form RNH2, I am telling you. Then 1H from the RNH3X, that will come out as H plus. NOH, OH has minus. Then this OH minus and H plus will form water. Correct? Then second product, RNH2 was the main product. Second product is H2O. Then now you can see that on RNS3X, one H gone. Then now 2 hydrogen is remaining. Means RNS2 is remaining. What will happen to the X? X is also attached with R. RNS3X was there. Then that X and NOH, Na is plus, and this X will also go as X minus. Then it will form NaX. Then 2 product is over. Then now what is remaining? RNS2. Only RNS2 is remaining. That is the primary amine. Then N was having positive charge. Now it is neutralized. Correct? N was having positive charge. Then when first H went as H plus, then it went leaving electron. Then N was having positive charge, that is neutralized. Hence you will get RNS2. Then RNS3X plus NOH. You will get 3 product. Main product is RNS2, free amine, plus H2O plus NaX. Ammonolysis has the disadvantage of yielding mixture of primary, secondary and tertiary amine, and also a quaternary ammonium salt. This is actually a negative point or disadvantage of ammonolysis of alkyl halide, because here you will get a primary mixture of primary, secondary, tertiary, quaternary. That this is the disadvantage. Ammonia has the disadvantage of yielding a mixture of primary, secondary and tertiary amines, and also a quaternary ammonium salt. However, primary amine is obtained as a major product by taking large excess of ammonia. If in the process you will take more ammonia, primary amine, if you want to make primary amine is obtained as a large product by taking large excess of ammonia. Okay, the order of reactivity of halides with amide is, if you will take a halide like Ri, RBr, RCl, then with Ri it will be fast. Order of reactivity I am telling you. Order of reactivity of halides with amine is Ri is greater than RBr. RBr is greater than RCl. Okay. This I have told you ammonolysis of alkyl halide. Now one question only here you should know. This type of question is asked in examination. That is the chemical equation you have to write. Okay. That question I am telling you, that you have to write chemical equation. Three you can say equation you have to write. First, reaction of ethanoic NH3 with ethyl chloride. You have to write reaction with this. Okay, you have to write reaction of ethanolic ammonia with ethyl chloride. Just to think over. Now I already discussed Rx. Rx means alkyl halide. Then C2H5Cl is also alkyl halide, ethyl chloride. Then reaction you have to write reaction between NH3 and ethyl chloride, simple reaction in presence of ethanol, that is called ethanolic NH3 with ethyl chloride. Then what will be the reaction? Then reaction is very simple, already you know. Ethyl alcohol, it is just like Rx plus NH3, simple reaction, Rx plus NH3, correct? Then here you know what I discussed, already explained, same way. 1H will go with Cl, ethyl chloride, Cl as minus and C2H5 will be plus. Then NH3, that H will go as a H plus. Then N will get negative charge. Now that N will negative charge and ethyl is positive charge. Then ethyl will join to the N. Then NH3 was there, now it will be NH2. Very simple way. It means you will get C2H5 NH2. Correct? Again further, because two more H is there, then again second ethyl group also will join. Then now with N, two ethyl group joined. Now it became secondary. Now one H is there remaining, that also can react with ethyl chloride, and third ethyl group can also join. Correct? Means with N now three ethyl group is attached. Correct? Then first you got ethanamine with first NH3, with second you can say ethyl chloride, with first ethyl chloride you got ethanamine. Only one ethyl is joined with N. In presence of second ethyl chloride, you will get N ethyl amine, N ethyl ethane you can tell, N ethyl ethanamine. Correct? This is a correct name. N ethyl ethanamine. Two ethyl group is attached with nitrogen. Now this nitrogen has one more hydrogen. Hence third ethyl group also can join. Then it will be a tertiary actually, but total three are there. Then it will be N. Two ethyl group nomenclature you have to remember. N diethyl ethanamine, means in ethanamine two ethyl group attached. In ethanamine what you got in the beginning, in that extra two ethyl group attached. Then ethanamine you are taking as a standard primary. Then name will be N diethyl ethanamine. Second reaction you have to write, that is the ammonolysis of benzoyl chloride. Reaction you have to write. Okay, ammonolysis of benzyl chloride. And also you have to write reaction of amine so formed with 2 moles of methyl chloride. You have to write the reaction first with ammonolysis of benzoyl chloride, and second reaction also you have to write reaction of amine so formed with 2 moles of methyl chloride. Very easy. Benzyl chloride. Benzyl chloride means with benzene, CH2Cl is attached. Okay. Benzyl chloride, not chlorobenzene. Here Cl is not directly attached to the benzene. CH2Cl is attached to the benzene ring. Remember. Always you remember. CH2Cl is attached to the benzene ring. Okay. Then it is called benzyl chloride, means C6H5CH2Cl. Then now you have to not bother for C6H5. Now what is remaining now? CH2Cl plus NH3 plus NH3. Then same reaction will take place. This you can consider that it is a group C6H5CH2Cl. Only you have to bother for CH2Cl. In that also, just like Rx, you consider C6H5CH2 just like R, RCl. Then you know what will happen. It is reaction with NH3. R is just to keep always common. R you consider Rx. Then after that you know Cl will go as a minus. Then this R will become, where R is equal to C6H5CH2, that will become positive. Then Cl will go as a negative. Then this R will become positive, and from the NH3 same way H will go as H plus, N will get negative. Then this R will join with R positive will join with N negative. Simple way. Then now you got C6H5CH2 NH2 means benzyl amine. R now you add, R is equal to C6H5CH2. You got benzyl amine. Now second reaction now you have to consider. Okay, because now you got benzyl amine. NH3 was there, now it became NH2. It is joined with benzyl group. Then benzyl amine you got. Now what will happen when it will react with methyl chloride? Then again it is very easy. Methyl chloride, it is just like Rx. Now in this amine 2 hydrogen is there. Then you remember same way. Now again methyl chloride you consider as a Rx only. Here R is equal to methyl. Then now two molecules, 2 more step it will go. With 2 methyl chloride you have to consider. Each time one hydrogen will go, and every time in its place R will join. R means here methyl group will join. Then if you will take 2 methyl group, then methyl chloride will take 2 molecule. Then already 2 hydrogen is there in amine, benzyl amine, 2 hydrogen is there. Then this 2 hydrogen will go as a 2 plus, 2H plus and 2Cl minus from methyl chloride. They will form HCl, 2HCl. Then what is remaining? That methyl will be positive, and this nitrogen will be negative. Then because 2 hydrogen gone, one step by step reaction will take place. Then first CH3Cl. Cl will go as a Cl minus, CH3 will be plus, that will join with nitrogen because nitrogen has negative. H gone as H plus, and nitrogen become negative. Then R will join means methyl will join. Now one more H is there. Then in next step that also it will go as HX means HCl, and methyl will join there. Okay. Then you got now same way nomenclature, NN dimethyl, phenyl methanamine. Again here you understand with phenyl methanamine 2 methyl group is attached. and its name is NN. 2N is joined with nitrogen, and you are considering C6H5NH, C6H5CH2N. That is actually a standard primary. With that 2-methyl group is attached. That's why NN dimethyl phenyl methanamine. Correct? Remember, this is useful. This question is asked in a nomenclature also. Okay. Then NN dimethyl phenyl methanamine. Phenyl methanamine, because phenyl group is attached with CH2NH2. Then you have used the word phenyl due to C6H5, and then methane you are using the word for CH2. That carbon is there, one carbon. That's why name became NN dimethyl phenyl methanamine, because with that carbon NH2 is attached. Now next reaction I am telling you, method of preparation, that is the reduction of nitriles. Nitriles means C triple bond N, cyanide, RCN, but between the C and N triple bond is there. Nitriles, that is called actually nitriles. Nitriles on reduction with lithium aluminum hydride, means LiAlH4. This is reducing agent. Nitriles on reduction with lithium aluminum hydride or catalytic hydrogenation. Catalytic hydrogenation produce primary aniline. This reaction is used for ascent of amine series, that is for preparation of amines containing one carbon atom more than the starting amine. This is the importance. This I told you that ascent of amine series, ASCENT, ascent of amine series, means for preparation of amines containing one carbon atom more than the starting amine. Reaction I am telling you, RCN. Then here C and N triple bond is there. Then always you remember, if this thing, any reducing agent is there, okay, here it is a lithium aluminum hydride. Then if reducing agent is there, then always you keep in mind you will get hydrogen as much as you require. Same way, presence of oxidizing agent, you will get oxygen as much as you require. You have to not think in oxidizing agent and reducing agent, you have to not think for this thing number of molecules. Only you think it will supply hydrogen gas simply, or oxidizing agent will supply oxygen, okay, as per requirement. And this here you have to also think it will supply one hydrogen, like that, H radical form also, H radical form, H one electron, oxidizing agent O1 electron, like that way. That also you have to consider. When 2H will be there, then obviously H2, but 1 by 1 it will supply. 2 oxygen means O2. But you think like this way, then you can understand the reaction easily. Here I am telling the reaction RCN in presence of lithium aluminum lithium aluminum hydride LiAlH4 or catalytic hydrogenation. What will happen? Means catalytic hydrogenation means sodium amalgam in presence of ethyl alcohol. That is called catalytic hydrogenation. Sodium amalgam in presence of ethyl alcohol. Any one condition, either hydrogen gas in presence of nickel or sodium amalgam in presence of ethyl alcohol, it will supply hydrogen simply. Then now see C triple bond N is there, RCN, cyanide is there. Then now you can understand what will happen, that this triple bond will become single bond, two bond will break. When two bond will break, then obviously that hydrogen will join there with carbon also and with nitrogen also. Because when bond will break, carbon also will take electron, nitrogen will also take electron. Electron wise radical form also you can consider. Quickly you will understand. Whenever bond will break, one will take both. In this way, for understanding purpose you can consider, or charge wise also you can consider. Okay, for understanding purpose. If we can say if electronegative atom is there, then obviously that both electron of the bond will be with electronegative atom. Always for the bond, sharing of electron will be there. Correct? In covalent bond, sharing will be there. Then because it is electronegative, hence one electron already it belongs to that atom only. Other also it will take because it is electronegative. Then anyway you can understand radical form, that you can also understand that both have shared, then one electron will take. In this way also you can understand. Or if you will think that electron is taken by electronegative atom, then that will be negative and other will be positive. Other carbon will means from the carbon where from where electron gone, that will be positive. Anyway you can understand. Okay, but for better understanding, you radical forming can understand that both will take one electron. Then now here, when one bond will break, CN bond, two bond will break, then hydrogen will give one electron, then one will go to the C, other will go to the N. One hydrogen will come to the N, another will go to the C. Then now when one bond broken, then one hydrogen each, means carbon one hydrogen and nitrogen one hydrogen, means hydrogen joined with carbon one hydrogen and one hydrogen with nitrogen. And now if second bond will break, then same thing will happen. Again one hydrogen will join with carbon, other will nitrogen. Then what you will get? You will get RCH2NH2. Very easy way you have understood. RCH2NH2. This is actually amine. Okay. Now here you can see one carbon increased. In the beginning it was RCN. Alkyl group was there. Now CN, that C now convert that due to this C, one carbon increased. One carbon increased. That is called ascent of amine series. That is one carbon atom here more than the starting amine. Okay. Now next reaction I am telling you, reduction of amide. Amide means CONH2. Amide means CONH2. Then here the amide on reduction with lithium aluminum hydride yield amines easily. Now easily you can understand. RCONH2. C and O, that is a double bond. C double bond O, and with that C, NH2 is attached, CONH2, that is called amide. Then here it is RCONH2. Then here again in reaction is taking place in the presence of reducing agent, means lithium aluminum hydride, or also water will be there. In presence of water, that is finally hydrolysis will take place. It means H2O must be there. Then here again what will happen, that this oxygen CO, that will go as water with hydrogen. One oxygen require two hydrogen, and in its place, oxygen place, two hydrogen will join. Then now that carbon became CH2, correct, and NH2 will be as it is. Then now you got RCH2 NH2. This is the amine. This is called amine, correct. RCO NH2 was there, then only already NH2 is there, only you want to remove this oxygen to make the amine from amide. CO NH2 is already there, then only CO, that O should go, then a reduction you will do, then O and hydrogen they will make water, and it will go as H2O, and in its place one oxygen means two hydrogen, equivalent to two hydrogen, then two hydrogen will join there because carbon oxygen double bond was there, then two hydrogen will join, it will form RCH2 NH2, correct. Then this I have told you, this things, reaction, preparation of amine from amide. Now next reaction I am telling you, method of preparation, Gabriel thialamide synthesis. Gabriel thialamide synthesis, this is a very very important reaction. Gabriel synthesis used for the preparation of primary amines. Thialamide on treatment with ethanolic potassium hydroxide forms potassium salt of thialamide. With potassium salt, actually it will form potassium salt of thialamide, which on heating with alkyl halide followed by alkaline hydrolysis produces the corresponding primary amine. Aromatic primary amines cannot be prepared by this method. Why? Because aryl halides do not undergo nucleophilic substitution with the anion formed by thialamide. Reaction I am telling you, by reaction all thing will be clear. Thialamide, what is the structure of thialamide? A structure easily you can write. It is a complex structure, but you will write easily. See here, just to think, NH3 you think, then you think like that, NH3, from the NH3 two hydrogen gone. Then from each hydrogen, actually when hydrogen gone, then with in the place of that hydrogen, now think that CO has joined, CO, C double bond O, that has joined in the place of hydrogen, because H will go as H plus, then N will become negative, and carbon will be CO, that carbon will be positive, that will join with N. Other also H, another second H also it will go as H plus, N will be negative, and another it will join with another CO. Okay, then now it will make bond with CO. Correct? After that, very easy, that both CO will join with benzene. Both CO will join with benzene with adjacent carbon, means just near to each other. Correct? Means suppose carbon 1, carbon 2. One will join with carbon 1, other will join with carbon 2. Carbon has 4 valency, then 2 valency over with oxygen, 1 with nitrogen, and 1 with benzene ring. It has joined. Same way, another CO, same way. 4 valency, the 2 is joined with oxygen, 1 with nitrogen, and other with benzene ring. Okay, carbon number 1, carbon number 2 continuously adjacent. Then this is actually thialamide. This is called thialamide. Okay, thialamide. Thialamide. PHTHALIMIDE. PH is silent. Thialamide. Then this will react with KOH reaction, you understand. This thialamide. In thialamide, N has H. 3 was there, 3 hydrogen. 2 hydrogen replaced. Now 1 hydrogen is there with N. Now see the role of this hydrogen. In the presence of KOH, what will happen? Easily you understand. KOH means K plus, OH minus. And here NH. H is plus. H will go as a H plus. Then N will be negative. Then with this negative, K will join. K is positive, that will join with N. Now it will become NK. N minus and K plus. And this H plus and OH, KOH, that OH minus will form water. Then now see, you got the salt, NK, thialamide salt you got. Okay, now after that, when it will react with RX, then now you are understanding what will happen. RX, X will go as X minus, R will become positive. Here NK is there, N is negative, K is positive. Then K will go to the X and it will form KX. Then R is positive, N is negative. Then R will join with N. This is called N-alkyl thialamide. N-alkyl thialamide, because from N-alkyl group R is attached. That's why it is called N-alkyl thialamide. Like that way, same way in the place of H, NH is there in thialamide, NH. Now we consider in the place of H, R is there. Or you can tell already what you got, N-alkyl thialamide. Support is the starting. Starting material is N-alkyl thialamide. Actually, you want to form NH2, RNH2, you want amine. Then now from this N-alkyl thialamide, how will you get RNH2? That you have to understand. Then now that here, what will happen when it will react with NaOH, then here what will happen? This reaction is important to understand. That here in thialamide, C and N bond was there. That bond, both bond will break. C and N bond will break. Then N is electronegative and carbon is, N is electronegative and electron will taken by the nitrogen. Then obviously carbon will become positive and nitrogen will become negative. Correct? This you remember. Then now what will happen? That carbon will become positive. Then with this positive, this positive carbon, NOH you have taken reaction taking place with
in the presence of NOH. Then here NOH, that OH bond will break, O and H bond. You will get NaO minus H plus, NaO minus H plus. Then this NaO that will join with carbon. That will NaO, O is minus, then O will join with carbon and it will form CONA bond. ONA joined with carbon and it formed CONA. Same way second bond CN, that also broken. And again here 2 molecules of NOH we have taken. Then again ONA will join here, ONA. Then now that NR now became free. NR became free, having 2 electrons due to the breakage of bond. You can tell when 2 bonds broken, then it has capacity to make 2 bonds. Because electron is with it, carbon become positive, means electron is with nitrogen, NR, hence it can make 2 bonds. Then now this thialamide salt, that bond that is a broken CN bond, then NR became free. One product what I told you now it became with C double bond O, ONA, and second again C double bond O, Na, and this both CO is joined with benzene ring. Then that is separated, and main thing is that NR became free. Now this N is in a position to make 2 bonds. Hence, if you can say this NR now it became free. Then with this N, 2H can join. 2H can join. Then from where it is 2H will come? Then you have seen NaOH, H gone as H plus. 2 molecules NOH you have taken, then from each 1 hydrogen H plus gone. Then this 2H will come near the N. Because N has electron, this nitrogen has 2 electron, means it has capacity to make 2 bonds. Then it will make bond with 2H. Hence you will get RNS2. Already methane R was there. Then now this H has electrons. It can make 2 bonds. Then A2H plus came, H plus to the NR, and it formed RNH2. That is the primary amine. Okay. Now one more reaction I want to tell you, that is also very, very important. In examination, these Gabriel thialamide synthesis, it is also asked. And now Hofmann, now I am going to discuss Hofmann bromamide, I can say Hofmann bromamide degradation reaction is very, very important, that I am going to discuss. Hofmann bromamide degradation reaction. Hofmann developed a method for preparation of primary amines by treating an amide with bromine in an aqueous ethanolic, here listen carefully, condition. Hofmann developed a method for preparation of primary amines by treating an amide with bromine in an aqueous or ethanolic solution of sodium hydroxide. That's why it is called Hofmann bromamide degradation reaction. Then here this things condition I have told you. Sodium hydroxide must be present. Either it should be aqueous or ethanolic, and bromine must be present. In this degradation reaction, migration of an alkyl or alkyl groups takes place from carbonyl carbon to the amide to the nitrogen atom. This is important, that in this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. Means actually alkyl group will be with CO group, carbonyl group, but that alkyl will come to the N, it will join to the N of NH2. Okay, this you remember, it will come to the N, simply you remember. In this degradation reaction, migration of an alkyl or aryl group takes place from carbonyl carbon of the amide to the nitrogen atom. The amine so formed contains one carbon less than that present in the amide, because alkyl group is moving to the carbon, correct? Then alkyl is moving, then obviously carbon will, at least alkyl will have one carbon, then there will be less than, there will be decrease of one carbon, and so what will got amine? That will be less, one less than the starting. Then here reaction I am telling you, RCOONS2, RC double bond O, RCONS2 plus Br2 plus 4NOH. This reaction is most important reaction for all exam. Okay, RCOO, wherever chemistry paper will be there, this type of question will be asked. RC double bond O, NH2 plus Br2 plus 4NOH. Then Br2 and 4NOH is this condition. Then now what will happen? That here oxygen will go as, it will go as this H2O only, but not directly, but you understand that O will go. Then here what will happen? Here just to understand that R will come to the RCONS2 is there, then R will, just arrangement will take place, means just movement of R to the N. Now R is joined with carbon, now it will join with N, that's simple, and that C and NH2 bond will break. C and NH2 bond will break and R will go to the N. Then how it is possible? That for that purpose, to make all the things, bromine and NOH is required. Then when R will come to the N, it will form RNH2, main product, primary amine. Then here because it is R is joining with N, means N is negative, means when C and N bond will break, carbon will become positive, N will become negative. N will become negative. Then now R and C bond also will break. Means RCONS2 was there. Then both bond will break. R and C bond will break, and C and NH2 bond will break. Then here NH2 will take electron. Then N will become negative. N will become negative. And because carbon is now becoming positive, then when this R will break bond R and C, then electron will be taken by carbon and R will become positive. Because when C and N bond broken, N has taken electron. Carbon, because N was electronegative, carbon became positive. Now when R and C bond will break, then now C will take the electron. R will become, when C will take the electron, R will become positive. And this R positive will join to the nitrogen, negative nitrogen. This R positive will join to the N negative. Then now your main product you got R joined to the N, R positive, R plus joined to the N minus. You got RNS2. Now you can see CO became free. When C and R bond broken, C and N bond broken, then CO became free. Carbonyl group, that CO became C double bond O became free. That will come to the NOH. That will come to the NOH and it will form Na2CO3, because here you will take more NOH. 4 NOH you will take. Then it will form Na2CO3. Na2CO3. Okay, because 4 NOH you have taken. Then 4 oxygen plus 1 oxygen of carbon. Total 5 oxygen is there. And 4 sodium is there and 4 hydrogen is there. 4 hydrogen, 4 sodium, 5 oxygen. Then how, and 2 bromine is there, a Br2. Now its role will come. Then Br2 is there, then obviously it will form 4 NOH you have taken. Actually, why you have taken 4 NOH? Because it is required. Obviously, it will become 4 NOH. Then bromine plus sodium, it will form NaBr. Then 2 bromine is there, that's why it will form 2 NaBr. Then out of 4 sodium, 2 is used up. Now 2 sodium is remaining. Then Na2, one carbon is there, CO, that carbon Na2C. Now oxygen you can see that Na2, 2 sodium is there, then possibility is only for Na2CO3. Then CO is there and 2 oxygen, 5 oxygen are there. Then now here 3 oxygen is used up in forming the NO2CO3. 2 sodium was remaining, 1 CO was there and 2 oxygen from NOH is used. It formed Na2CO3 and 2 more oxygen is there and 4 hydrogen is there. 2 more hydrogen is there. Correct? Not we have not used hydrogen. That is the 4 hydrogen was there, 2 oxygen you have used and 1 oxygen of CO. Total 3, 2 sodium. Then NO2CO3 formed and 2 NaBr, bromine is already utilized. Then now 4 hydrogen and 2 oxygen is remaining. 3 Na2CO3, 3 oxygen is used up. 2 oxygen and 4 hydrogen means 2H2O. Then you got RCONS2 plus Br2 plus 4 NOH. You got RNS2 plus NO2CO3 plus 2 NaBr plus 2H2O. This reaction is very, very important. And how Na2CO3 formed, that also you will understand. Correct? Because CO, carbon oxygen double bond is there. It means now 2 electron is with carbon. Out of 4 carbon tetravalency, 2 valence is there. Then now oxygen, 2 Na2CO3. Then 2 oxygen can join, single bond they can form. Then that is the and 2 when this carbon and oxygen making bond, single bond, 2 oxygen joined. Already 1 oxygen was double bond. Now 2 oxygen joined with carbon with single bond. Then each hydrogen is 1 negative. Correct? Then with that 2 negative, 2 sodium will come. In here was there in NOH N plus, that 2 N will go to the oxygen. Like that way it will form Na2CO3. Then I have told you that from this RCONH2 means from the amide you can form the amine. Okay, RCONH2 plus Br2 plus 4NOH, you will get RNH2 plus Na2CO3 plus 2NaBr plus 2H2O. Today I am stopping only here. Next class I will discuss physical properties. Okay, thank you.